Hello. Hey, there we go. Hello. Are we having a good conference? Yes, we've made it to the end, finally. I'm aware I'm the last talk of the conference, so I will do my best to keep you awake and to keep myself awake, as the jet lag is now starting to really creep in. But today I want to talk to you about full stack development with Swift and how we can use Swift on both iOS and the server and share code between the two. And by the end of this talk, you're going to go back to your companies, you're going to go back to your work and your projects, and you're going to go, I want to server-side Swift all the things. So, quick introduction before we get going. I run a company called Broken Hands. We do server-side Swift consultancy and training and workshops, etc. I'm a core contributor and one of the moderators of the Vapor framework. I'm the server-side Swift team lead at raywendlick.com, so I am completely unbiased when it comes to server-side Swift. You can follow me on Twitter and Slack and GitHub and Discord, etc., as 0xTim. So if you have any questions, feel free to get in contact. And I organize a couple of meetups and the server-side Swift conference, which is held every year. So, some audience participation. Let's get you awake. How many of you consider yourself to be full-stack developers or write some sort of back-end code? Not that many. Of the people who have put your hand up, how many of you work for companies with, say, more than 40 people? So it's less. So generally what we see is, especially with big companies, is that the back-end teams and the front-end teams are very separate. And this is a problem. So why do we want to do full-stack development? Well, the world has kind of moved on to agile development. Back in the supposed good old days, we had the waterfall method, and your specs and API and your design would be all decided up front, and the back-end team would go away, and the iOS team would go away, and they go away for months or maybe even years, and they come back together at the end, put it all together, and of course it would work first time. And of course no changes were required during that period, and no new features were thought about. And in reality, it doesn't work like that. We need to have good communication between back-end and front-end teams. And this is difficult. And if you have separate back-end and front-end teams, you really can't be agile. You can't adapt your business's needs and your users' requirements. If your back-end team's in a different building or a different city or a different country even, it really puts up barriers to entry to kind of establish that communication line. And how many of you have been in a situation where you need a new feature on the back-end or a new API and you've been told, file a Jira ticket, we'll get to it at some point? It's just not sustainable. And as well as this kind of move towards full-stack development, we're also seeing a move towards apps. Especially in the enterprise, companies are moving away from websites because they want native apps. They want to be able to deploy iPads into enterprise with native solutions that have real benefits, such as using the OS-specific photo role, etc. And progressive web apps, which have been touted for years by web developers as this golden holy grail, just aren't living up to the hype. They don't work. And that's the same with cross-platform solutions as well, like React Native or Cordova. They're great for kind of prototyping and building up kind of quick solutions, but as time goes on, they really start to creak. And we're seeing companies like Airbnb and Dropbox removing support for cross-platform apps and going to full native solutions. And there's many reasons for this, and most of them are just because you get a poor user experience. They're slow and they're difficult to use. They don't look like the OS. Certainly in the UK, most of the high street mainstream banks all use the same cross-platform stack and the same app template for their banking app. And it's really obvious because it's slow, it doesn't look like the OS, it still doesn't support the iPhone 10 and above because it still has black bars. And I signed up for a new bank account earlier this year, and I downloaded the app, as you do, and I launched the app, and the first half of the page was a cookie notice on an app. And you dismiss it, and you go along, you close the app, you open it again, and the cookie notice comes back up. Users aren't going to want to use your apps if you're showing cookie notices in native apps. And we haven't even got on to talking about things like accessibility and dark mode and adding keyboard support, which if you have cross-platform solutions, are really difficult to do. And we've heard about today and yesterday how important those things are. And even old devices, your JavaScript-heavy cross-platform solution may work fine on your iPhone 11 Pro, but some of your users may still be using an iPhone 5, and they're not going to have the best user experience. So in my completely unbiased opinion, all roads lead to Swift. So why do all roads lead to Swift? Well, Swift is a fast-growing language. It's hugely popular. We all love it. We've all heard today and yesterday how good it is. It's backed by Apple, so there is some kind of knowledge, kind of hope, or at least confidence that it's not just going to get discarded, like it would be if it was, say, owned by Google. And it's also open source, which is a really unique opportunity in our industry to be able to fix bugs in the language ourselves, or even steer the direction of the language using the evolution process. It's a modern language. A lot of the existing languages that are used, especially on the back end, have been around for 20 or 30 years, and they're carrying a lot of tech debt and kind of cruft from all this time. And Swift's very open about the fact that it will steal the best parts of other languages to make it great. Swift is a really, really safe language. It's strongly typed, it's statically typed, which means that whole swathes of errors just aren't possible in Swift. Things like null pointer exceptions, you can't get those if you use optionals correctly. And it's a fast language. It has the potential to be the same kind of near performance level of C, which makes it applicable for kind of any kind of use. But the biggest reason why you should use Swift is because it's not JavaScript. Now that's a bit of a low blow, and I'm not going to bash JavaScript completely, the whole thing. And it certainly has its use, and it's definitely been useful. And it's the same with other languages such as PHP, but there are now better solutions, and we should consider them. So let's talk about the server. So what's Vapor? So Vapor is an open source web framework written in Swift. It was created by a guy called Tanner Nelson, and him and Logan Wright build and maintain it. And it allows you to build web APIs and server applications, etc., in Swift. It's built on top of Swift Neo, which is Apple's non-blocking, event-driven I/O framework, and it does all the heavy lifting, the low-level gnarly stuff of interacting with the kernel and handling HTTP connections. So that allows Vapor to provide a really nice API on top. And speaking of APIs, Vapor has a really nice Swift-like API. It's written by Swift developers for Swift developers. So if you're coming to it, you can read it and understand what's going on. And it makes use of modern Swift features. When Vapor 3 came out along with Swift 4.1, it was using codable and key paths. And Vapor 4, which is currently in beta, uses property wrappers throughout all of the database stuff because it provides really nice, clean abstractions. And Vapor has an awesome community. A really, really substantial community of thousands of developers who are all active, all really helpful and engaged, where you can ask questions and get solutions to your problems. So why would you use Vapor as a developer? Well, to start with, you get happier developers. Now, why do you get happy developers? So I have this really scientific graph here with functionality on the x-axis and developer happiness on the y-axis. And as you're building your app, you start an app, you realize, well, I need a backend, I need an API, because all apps do these days. So if you start, you're going to use something like CloudKit. It's really easy to get going, it's baked into the OS, but its functionality is quite limited. So you're quite happy because it's easy to use, but then as time goes on, you realize, I need something a bit more. So you might pick something like Firebase. Now, Firebase is good, it has a lot more functionality than CloudKit, but it's a little more opinionated on what you need to do. And you end up duplicating a lot of your business logic in the client apps if you have more than one client. And so your kind of happiness drops a little bit. And then as time goes on again and again, you realize, I need a full-fledged web framework. So it could be anything like Laravel, Node.js, or Rails. And so you use that, and your functionality is all the way over there because you can do anything you want with it. But your happiness has dropped because you have to learn another language. You have to context switch, and you're not using Swift. So there is a solution, which is Swift, because you have all the functionality, because it's a full web framework using Vapor, but you get to keep to use Swift, so your happiness is way up there. You also get a compiler. Now, for iOS engineers, this is, sure, that's not news to us. But if you tell web developers that they can find the errors in their code before they ship it to production, it blows their minds. You get the same tooling as you do in iOS. So we've all invested time learning Xcode for all its faults. It's a great IDE. And we know how to use Xcode. We know how to use instruments to profile our apps. And you can do exactly the same thing with the exact same tools writing server-side apps. You get debugging support in Xcode. So if you need to put a breakpoint in your code when you're handling network requests to work out what's going on, just put a breakpoint in and you can step inside. And because Vapor is written entirely in Swift, it's easy to understand what's going on and you can step in and find out what's happening. So if you're a business, why would you allow your developers to use Swift on the server? Well, like everything, it comes down to money. Vapor and server-side.swift with Neo are completely asynchronous, they're non-blocking, and even the database drivers are non-blocking, which is pretty rare. And this allows you to handle more requests per second than you would with a synchronous architecture, which means that you need less servers. But the big benefit of using Swift on the server is the memory footprint. So a typical Vapor application, typical server-side.swift application, has a memory footprint of about 6 megabytes. That's tiny. If you compare that to something like JavaScript or PHP, you're talking orders of magnitude different. And anyone who's ever used any kind of Electron app on their laptop, like Slack, knows how much memory it requires. And because you need less servers and less memory, it saves you money. And companies have seen tangible benefits of around 80% when moving from PHP to Swift, which is a huge amount of money to save. And it's also safer. Because Swift is strongly typed and statically typed, and it's a compiled language, you're not going to get errors that you get in kind of dynamic languages. So you're not going to be woken up at 3 o'clock in the morning because your server's gone down. So how do we deploy it? How do we use it? Well, most people know, but not everyone knows, that Swift works on Linux. It's officially supported on Ubuntu. You get Foundation, you get XCTest, and you get the core library. So because it works on Ubuntu, you can deploy it into Docker, which means you can deploy it pretty much anywhere. And there are build packs available for platforms like Heroku, which allow you to deploy your application to the internet with a single line on the command line. Now, the question I get asked the most when I'm going into companies and talking to developers is it ready for production? Yes. Let's just say yes. It definitely is. Certainly at the start it was not, but now we're kind of reaching a level of maturity. Swift 5.1 moved the default encoding type for strings to UTF-8 from UTF-16, which provided a huge performance benefit for running server applications, and it brought it in line with the rest of the world. Swift Neo 2 has provided some stability to the ecosystem and a level of maturity that we're seeing. And Vapor 4 is really kind of built on its experience and knowledge and writing a web framework for production-level, high-intensity apps. The Swift Server Working Group, which meet every month, and they're founded by people from Apple and Vapor and the community, are really kind of, their focus this year is to build a big ecosystem. So they're concentrating on building packages for logging and metrics and monitoring, all the things you'll need for deploying in the enterprise. There's things like OpenAPI for defining your spec, database drivers that are battle-tested and hardened and you know that work written in Swift, and things like authentication. And a great example of the community coming together is a memory leak that was posted on the Swift forums earlier this year in Vapor. And people from Apple and people from the Swift team, people from Vapor and IBM and the community all came together to fix this really gnarly bug in the MySQL driver. At the conference, we've had 2 years of the conference now, and companies talking about how they're using it in production. And some highlights. Mercedes-Benz, a lot of their in-car telematics systems are using Swift on the server on the back end. A lot of their in-house sales stuff is written using Swift on the back end. ING Bank, which is quite a big bank in Europe, and their subsidiary, the Banking of Things, they're processing transactions and sending and receiving money with Swift. So they have confidence that Swift will work making financial transactions. Nodes are a huge agency in Europe. They're one of the sponsors of Vapor, actually. And they've gone all in and said, we're writing all our backends in Vapor. And they have some pretty big clients. Allegro, who are Poland's Amazon, effectively, they're an e-commerce site. They gave a really interesting talk a couple of years ago about how they've moved some of their image processing libraries from Java to Swift and have seen huge performance increases. Amazon, many people don't know, but if you've ever watched a video on Amazon Prime, that video has gone through a server-side Swift application. Some of their own coding stuff is done in Server-Side.Swift, and they gave a really interesting talk this year about their own framework called Smoke, which is Swift. The BBC, a lot of their CI stuff is wrapped using Server-Side.Swift applications, mainly because I used to work there and I forced them to do it. And of course, Apple. If they're going to be investing this much time and money and engineering effort into things like Swift Neo and this working group, you can be sure that they're going to be using Swift on the server. They'll never explicitly say, I would put a lot of money on saying certainly some of their iCloud and backend infrastructure is using Swift on the server. So let's have a little bit of a demo. Because I could talk all day, but it's much more fun seeing it in action. So what I wanted to show you today, there we go, is an example of how you can share code between your iOS applications and your server applications. So I have an iOS app here. It's a reminders app or a to-do app, like any good getting started application is. And I have a reminder model, and I have a user model. They're fairly standard. They have just based on foundation, and they're codable types. And I want to share these models with my server, rather than duplicating the code on both sides. So, is this one on? It is. Awesome. So what I'm going to do is, can you hear me? Yeah, it's on? Cool. So I'm going to create a new Swift package. So in Xcode, I can do a file new Swift package, and I'm going to call this reminders core. And I'm going to put it in the same directory just for simplicity's sake, and just to add it to my iOS application for now. And as Ellen showed, it creates a really nice kind of template for you. You get a README, you have a manifest file, your README, even some tests to make you write some tests, and the sources directory. So I'm just going to drag my models over into that package, and that's my package written. I don't have to do anything else. My package is all done. So I'm going to go into my application and just add that new library as a dependency. And then if I build it, I'm going to get some build errors, because obviously I need to import the new module. So let's go ahead and fix those issues. Cool, and my build is now successful. So I've now pulled out all of my shared models into a separate package, and I'm using them in my iOS app. So I'm going to close Xcode for now. And I have my server application here. So I'm just going to open that up in Xcode as well. So I've cheated a little bit here, and I've done some pre-work, kind of expecting some of the stuff to be here. But I can just go into my package.swift, which is like your pod file if you're using CocoaPods. And I'm going to add the new package as a dependency. So that's just referencing the folder I created earlier. In a real app, you'd obviously use a real package on GitHub to keep it all in sync. But if I save that now, I should be able to see that it has pulled in, you can see down at the bottom at the back, my package is a local package. So I'm going to go into this extension file here, and I need to make my types for my share package work with Vapor. So I'm going to write some extensions. So I'm going to make my user conform to SQLite UUID model. And this just tells Vapor how to use it as a model in the database and how to interact with it and query it. And as you can see, it's a really complicated extension. I don't have to do anything with it. Vapor will infer a lot of it for you. I'm then going to make it conform to content, which is Vapor's wrapper around Codable. I'm going to make it conform to parameter. And this allows me to send the user as a kind of an ID, so I can do /reminders or /users/1, and that will convert it into a user model for me. And again, I don't have to write any code for that. And finally, I'm going to write an extension and make it conform to migration. Now, this is how Vapor knows how to create the tables in the database for you. So it's, again, really complicated. You do that, and Vapor will knows how to create the tables. It knows what the column names are. It knows what the column types are. So I'm going to do the same for my reminder. This one's an SQLite model instead of an SQLite UUID model because the ID is an int. So I make it conform to contents and parameter. And finally, I'll make it conform to migration. Now, I'm going to do something a little bit different in the migration here. So my reminder model has actually a reference to my user. And I want to set up a reference in the database to make sure that that's kind of ensured. So I'm going to override the prepare function here. I'm going to create the table. And then I need to create all the columns in the table, and there's a really handy extension for that, so I can do that, and that will create all of the columns necessary in the table. And then I can add a reference from the user ID property on the reminder to the user table ID column. And because it's using key path, it's all type safe here. So you're not going to be making any mistakes when it goes wrong. So if I build that, hopefully that should build successfully. Yep. And then finally, I'm going to show you how to create some routes. So in this controller here, I want 3 routes for my reminders. I want to be able to create a reminder, get all of the reminders, and get a single reminder. So we're going to do a create handler. And this is going to return a future handler. So I mentioned earlier that Vapor is asynchronous. So there's concept of futures in Vapor. And this basically means that at some point in the future, once it's being created in the database, I'll return it. So I'm going to decode the reminder object from the JSON body. So I'm going to send it as a post request as JSON in the body. And so this returns a reminder once it's been decoded. It just uses JSON decoder under the hood, nothing special about it. And then I'm going to save it on the database. And that's all I do. And that will save it in the database and return it for me. I don't have to write any SQL. It knows what the table is. It knows what the columns are, etc. So we'll do a get all handler to get all of the reminders from the database. And again, I need to perform a query to get all the reminders. So we're going to do a query on the reminder table, and I just want all of them, and that's all I need to write. And you'll notice here that I'm not having to decode table data into Swift objects. Vapor handles that all for you. And finally, I'm going to write a handler to get a single reminder from the database. And this will return a future reminder again, because it's got to go and fetch it from the database. So I'm going to do this as if I send it to /API/reminders/1, for instance. So normally you'd have to parse that ID from the request and then make a query on the database. But in Vapor, actually, you just have to do this, and that does it all for you. So 3 lines of code there for 3 full route handlers for a REST API. So I'm just going to register my routes there. So a post request to API reminders is going to be my create route. So I'll just use my create handler. A get request is going to get all of them. There we go. And a get request to the ID, or the parameter in this case, is going to use the get handler. So that should then build, hopefully, fingers crossed. Excellent. So I'm going to close this and run it from the terminal, mainly because Xcode doesn't like having a package open in more than 2 different projects, unfortunately, currently. So this will build and run my server application. And you can see it's been successful there. Let's go away, Xcode. So I'm going to open my iOS app back up again and build and run it just to prove it does actually work. And you can see I have all my reminders and my users. Now I want to show you one more thing before we wrap up today. I'm going to go back to my server application. And let's say I want to add a new property to my user model. Let's say I want to keep track of when that user last updated their status, for instance. So I'm going to open up my user model, which it can't find, which is there. And so I'm going to just add a new status, which is going to be last updated, and that's going to be an optional date. Pretty simple stuff. And that's in my shared model. So now if I go to my user controller, I can then, in my update handler, when the user updates themselves, I can then just set the last updated to the current date. And that will build, so I can close that then, and then run it again. And I'll go back to my iOS project here. And in the users table, I have some code down here. I'm afraid it isn't Swift UI. I'm very sorry about that. I'm going to check to see if we have a last updated property on the user. Okay. If it is, I'll set the cells detailed text label to include that, so it will have their status. And their last updated time. And I have a little extension down here just to make the date look a bit nicer. And then otherwise, I'll just do what we did before. And then if I build and run that, I can then go to my users, click on myself, and let's say I want to update my status. And if I go back to my list of users, you can see it now shows my last updated time. You don't have to clap that. So that's not particularly impressive. We've all written table view controllers and changed some status. But if you take a step back and think about what just happened there, I've added a new property to my shared model. I've made use of it in my server application, and I've also changed it in my iOS application. And it hasn't taken me very long at all. And I chose date for a specific reason there, because dates are inherently really horrible to work with across APIs. You have to know what format your date's being sent in. You have to know, is this a ISO 861, is this an Apple special? And then you have to decode it on both ends. But because we're using Swift on both ends, we can just rely on JSON encoder and decoder to handle all of that for us. Cool. And that shows us the kind of power of being able to share our code across both the iOS app and the server app. So some next steps. I am not saying go away and throw away all your backends and rewrite them in Swift just for the sake of it. There is really no point in doing that. However, I am saying take control of your server applications. Especially if you're a big company with distributed teams, if you can write a small little microservice that's just for your app, do that. Especially if they're only for your app, because it doesn't matter. And the backend teams aren't going to prioritize stuff that's only for you. They're going to prioritize stuff that helps for everyone. And so it allows you to change and update your apps quicker. And this is a kind of really common pattern that we're starting to see in the mobile world of BFFs, which is backends for frontends. And one of the most common things I see when going out to companies is that they have iOS apps that have to call 20 different APIs. They have to aggregate all that data on the client. They have to handle authentication on the client. Whereas you can move all of that logic into a small little Swift app and update it as you go along. So if one of your APIs changes or you need to go and call a different API, you only have to update that small app and your iOS application doesn't have to change at all. And you don't have to go through app review. Just a quick plug there. There's the Vapor book that I've written for raywendlet.com. It's the official, unofficial book, which I wrote with the founders of Vapor. I actually have a copy here to give away. So come find me and I'll work out a way of distributing it. Thank you. some questions. Yeah. Excellent. Which IDE can set breakpoints, watch variables, etc. for backend Swift code running in Linux? That's a very good question, actually. So the tooling on Linux, I will be completely upfront, is not perfect at the moment for Swift. SourceKit LSP, which was a project that was announced last year, is basically going to hopefully change that. But I know that both VS Code and Vim can do breakpoints, and you get code completion and syntax highlighting, etc. if you add SourceKit LSP, so that should change that. How does Swift compare to Golang? That's a very, very good question. So Go is probably the language that's closest to Swift in terms of its characteristics for server applications. So for those of you who don't know, there's a language called Go. It was written by Google. It's becoming very, very popular recently for back-end applications. It's very similar in terms of its performance and memory usage to Swift, but it does have quite some fundamental differences in the language. Go has a fantastic concurrency model at the moment, which is why it's become so popular. It's very simple to write, and it's really easy to write asynchronous code. When Swift eventually gets a concurrency model, like async await, hopefully, fingers crossed, soon, that should kind of close the gap. And Go has no concept of generics, which means you end up duplicating your code quite a lot, which is kind of, those are the two main differences. How is the support for Vapor for Android? Well, if I understand the question correctly, it doesn't actually matter because you're just exposing a REST API, so your Android app can talk to it absolutely fine. How well was this question answered? Very well. I shall skip the survey there. Which database is best to go along with Vapor? Vapor currently supports MySQL, SQL, PostgreSQL, MongoDB. There are community drivers for DynamoDB, CouchDB. I think that's it currently, so most of them. Postgres is probably the best at these days if you need something with SQL, I would say. How long have I got? I could do this all day. 3 minutes, excellent, right. You're staying till the end. How's the performance comparison between Java and Vapor? So Java, you have to run a JVM because it's byte code. So that's a massive memory hog. Anyone's ever run any Android stuff or Android Studio on your Macs, you know how much the JVM takes. So any kind of Java server-side applications need huge amounts of RAM. Swift does not. My team relies heavily on Spring for the backend. Any features we might miss when moving to Vapor? I like the confidence there, when moving, not if moving, when. It depends on your use cases. I would say that for 98% of people, there's everything there that you'll need to write backend applications. If you have some niche requirements, like talking to Microsoft SQL database, you might have a problem there. But remember, it's just HTTP calls and REST APIs, and it's just a web framework, so you can write it. And that's one of the cool things about being involved with Vapor at the moment, is because it's early days, you can really kind of write the first some package to do that. And final question, I've got a few more. Does Vapor integrate well with GraphQL? Was that Ellen by any chance? No. Yes, there is a package currently for working with GraphQL and Vapor. It will probably come out with Vapor 4 because they're relying on property wrappers, although I think they're waiting for 5.2 to fix a bug in property wrappers before the GraphQL library works properly. How to migrate from a server deployed in Java to Vapor, rm-rf star, and then Vapor new. How easy is it to make local HTTPS so I don't have to do local dev without changing app transport security values? You can run Nginx in a Docker container and point yourself at that with a certificate. That's probably the easiest way, I'd say. 1 minute. I shall do the last two. Can we consider a full stack dev without Android this day? Yes, because you are still writing a front end, but I am aware that you are missing out on a significant amount of the market there, and you're also missing out on the whole web front end as well. It's pick your poison, I'd say. There's nothing stopping you using a Swift application on the back end and a Kotlin application on Android and talking between the two. Swift has a lot of benefits for server-side.swift applications for server applications. Interesting, actually, a little anecdote. The Amazon team who wrote their server application for doing the Prime Video stuff, they weren't Swift developers who chose Swift on the server because they knew the language. They were Java developers who chose Swift because of its benefits. So we are seeing big companies take the risk and have confidence in Swift that it's ready for the prime time. And the last question is Vapor on cloud. Not sure what that means. If that means deployments, you can do pretty much anywhere that supports Docker. If you're talking about Vapor Cloud, that was a hosting platform that was shut down recently because it was a waste of time for the framework developers effectively. It was taking too much time away from us. So they're going to focus on writing a great framework instead of having to support a hosting provider. And that's every question there. Awesome.
Thanks, Tim.